Okay, welcome back. So we're going to be, after spending the last little while talking about the different pieces of Windows Azure, we're going to actually talk a little bit about building some apps and particularly, he says, working his mouth around that particular word. We're going to be talking about building apps with infrastructure as a service and platform as a service, the kind of mix of models that you're going to happen to have, because odds are pretty good that if you're coming from an existing application, if you're writing greenfield applications, you might very well want to go with the web roles, worker roles that were part of Azure from pre-June. But if you're working in a non-greenfield environment where you've got existing applications, you're going to want to find ways to get these things to kind of talk together. And so the point we're going to be talking about is why we mix models. Right? What kind of value does it make to actually have things move back and forth, or the different kinds of approaches that we've been taking? And so you may very well have dependencies out there on Active Directory, on the different databases that you happen to have, on SharePoint, on SQL Server. Some of you may still love Com+. I know I do. Message queuing. The list is huge in terms of the different things that you have out there upon which your applications might very well depend. And as much as it's really easy to sit back and talk about from an almost academic perspective is, hey, all you have to do is just migrate your application up. The reality is that almost every application I've ever been involved with has got dependencies that are the things that cause your application, or your estimates for your migration to go from 3 hours to 3 weeks. And so by being able to mix the models between the various pieces, you've got the ability to take advantage of the things that Windows Azure happens to have to offer, but still not break the dependencies that your applications currently have. So you can start the migration up to a virtualized environment. You can actually start to push out so that your infrastructure is being managed up in the cloud, and yet still have your applications work. And so that's one of the reasons why we start with that as well. And this is the idea of just simply migrating, right? The idea you have existing apps, you're trying to push them out there. And now you can, once you get it there, your ability to take advantage of all the other bits and pieces that Azure happens to bring to the table is much more extended. One of the things that we've done at ObjectSharp, we've actually, because we were running on Exchange, running off of Amazon website, or Amazon web server, web services. We were running virtual. We had actually racks at Rackspace in Vancouver. That was how we actually handle our infrastructure. And over the course of about the last 9 months, we've actually migrated our Exchange onto Office 365. We've taken our SharePoint, moved up into SharePoint Online. We're taking our website, we're moving into Azure websites. We put a couple of virtual machines up into Azure. So basically, we've migrated from having that kind of environment where we have physical and we have virtual up, and we're managing all of it, to a place where all of our infrastructure happens to be handled in within the Azure world for the most part. We still have a couple of physical servers. Our IT person likes physical servers, so he just needs to have things that he can touch on a regular basis. But the functionality side of what we're doing is all been pushed out there. And it was not done all at once. It was not like we went, boom, there's everything out there. We've been doing it slowly and steadily over a period of time. And that's the kind of way most companies are actually going to do stuff. And so that's what we're kind of going to be talking about in this particular session. Excuse me. So if you take a look at the Windows Azure service model, what you're basically looking at is, what you can see here on this slide is, you tend to think in terms of cloud, I want to say this is, at least as a starting point, this is the platform as a service model. You end up with this concept of a cloud service, and inside the cloud service you end up with web roles and worker roles, and each of them may be deployed onto different VMs, they may be deployed onto the same VM, it just really depends on how you happen to have configured it out there. But you can actually push your web application functionality in that particular into that particular model. Now, if we want to have those web and worker roles actually be able to communicate with our infrastructure, we have to have a way to be able to integrate our the implementation and the security model into that cloud services model. And so basically what Microsoft did is when they introduced the virtual machines, they actually have the virtual machines set up as being their own cloud service. And so, that's going to feel a little weird, but from a security perspective, you basically have got, if you're working with platform as a service on one hand, you'll have cloud service, and we're going to call it cloud service 1, so it lines up with the slide. and then you install a virtual machine. You put a virtual machine out there, or you put multiple virtual machines load balanced. It doesn't really matter. But when you push that second virtual machine out there, you now have cloud service 2. So that cloud service wraps the virtual machine from a security perspective. And then it becomes possible to, within the IaaS and the PaaS environment, to actually have those cloud services talk to one another. And there's a number of different ways that you can actually accomplish that. And yet at the same time, we also have to find ways to push that information back down, or potentially have information from the web roles, the worker roles, the VMs, get back into our on-premise environment. So you've got cloud to cloud, you've got cloud to on-prem back out to cloud. So you kind of have this nice little triangle of technologies that you actually have to work with. So the kind of patterns that we typically see when we're actually doing this, but there's about 3 or 4 of them that we're going to cover. So first of all, we've got the idea of connecting your cloud services with a virtual IP. And in this particular instance, what you're looking at is basically the following. You can see that at the top, the WA web is actually a Windows Azure web. So WA in this case is Windows Azure. So I've got a load balanced environment, port 80. I've got my web running out there in Windows Azure. And then on my on-premises functionality, I have got a load balance in front of a SQL server, in front of my database, or to be honest, in front of whatever on-premises services you need to expose to the website. And that's kind of what I mean. Your website's going to want to access your internal data. So how do I actually get my data back in from my SQL server and get it pushed out to the cloud? So mechanism number 1. This would be to actually access your data through a public endpoint. So the idea here is to have the website communicate with your with the database through a publicly available endpoint, TCP 1433. You can pick your own port number. That doesn't really matter, but it is going to be publicly available. And is it easy to set up? Yeah, it's easy to set up. Is it something that a network admins necessarily want to set up? That becomes a slightly different question. But it is the simplest thing to do, right? So incredibly easy. In your Azure web applications, in your web roles, you set up a connection string, points to where your load balanced endpoint is for your on-prem stuff. Off you go. Incredibly easy to set up. Don't have to change your applications one whit. Configuration-wise, not a complicated thing to do at all. Complete autonomy. So you've got complete control over your SQL database. You've got complete control over that load balancer, any routers that go on, the machine on which it sits, any security you have, anything that happens from the load balancer on back, it's completely under your control. Completely stateless functionality. So if you happen to switch out your virtual IPs, your database doesn't care. Right? If you happen to do something on the website, you add one, you change something, as long as it's going back to that same public endpoint, it's not a big deal whatsoever. Very easy to test. And so from a developer, you can just simply, again, run your website through your local app fabric and talk to the database and look. If it works there, it's going to work when you publish it out to Azure. Okay, so incredibly simple mechanism to set up. There are some issues because nothing's ever black and white. Okay, so first of all, higher latency. You're actually talking about having to make a call to a SQL server that's physically not in the same place. That is going to be slower. There's nothing really you can do about it. It's not, latency is decent, but it's not like it's going to be as if you were running on-prem. It's not like, I rephrase that, it's not going to be as if you were running both the website and the SQL database in the same basic environment, whether that is in the cloud or back inside of Azure. There is that element of security that I mentioned. You actually do have to have an endpoint that is publicly accessible that theoretically could be hit by people that aren't your application. Now, it's certainly possible to set up your router to only accept requests from certain IP addresses, which adds to that last point, management and deployment overhead. You actually have to make sure that you're setting up your config strings correctly. You have to make sure that you do have that router load balancer configured appropriately to get the kind of level of security that you happen to want in there. But straight, simple, easy to do, no hassle, no headache, no muss. It's a very simple, very straightforward solution. From a deployment perspective, you're looking at about 5 different steps. First of all, you deploy your VMs. You go into the gallery, you create a new one, you upload your VHD, you create your VMs however you want to create your VMs. customize them however you want to customize them. And you can, one of the things I didn't show when I was talking about the VMs earlier on because we ran out of time, but when you have the VM, you actually, the way you manage your VMs is to actually RDP into them. And you can go through the management portal, you can grab an RDP file, open it, and all of a sudden you're remoting into your virtual machine, and so you can do whatever you want. You're logged into the box, and off you go. Configure whatever endpoints you happen to want. So we're talking about you configure your public endpoints on the database side, set your firewalls up as appropriate, all of the things related to the network management that it goes on there. You can certainly test this locally. As I said, you can run your App Fabric. You can open up your Azure application, run App Fabric on your machine. Test to see whether or not it can go out through the firewall. You can do all of that kind of testing very, very easily, make sure it works, and then when you're finished, you just simply deploy your service. You push your web rules, your worker rules out to Azure, launch them, spin them up, and off they go, and everything should be just fine. So not bad from a deployment perspective, especially since once you have all the stuff working, any changes you need, basically just simply that last step. Okay, so that was with virtual IP. So I'm actually going out to a public network to do it. What if I want to use virtual networking? So in this particular instance, what we're talking about here is we're extending our network out to the site on which the platform as a service functionality happens to be running. You notice I still have my port 80 load balancer sitting out there. I still have my Windows Azure Web out there, but I'm using virtual networking to actually set up a connection between my cloud and my on-prem services. Like I said, I've extended my domain, I've extended my network out to the cloud. And so now my access ends up being more direct. I'm not going through a public IP. The connection between the Azure cloud service, the machine running there, and my on-prem is much more secure. Latency ends up going down because I'm not being routed through a public IP channel, but I'm actually running through stuff that is on the back side of things. So the kind of routing that has to be done is much less. I don't go through my load balancer. I don't go through I don't go through the mechanisms that I might have if I was opening up a public access to my data server. The cloud app has autonomy in that my cloud app is, again, it's part of my environment. I manage it all myself, so I've got the ability to add, remove worker roles, web roles as I happen to need to. Configuration is fairly straightforward. Still very stateless. This is fairly advanced connectivity, however, right? This is not, I'm not going to say it's not for the faint of heart, but this is advanced stuff. So if you're like me and you dabble in networking, which basically means I know what an IP address is, this isn't the kind of thing that you really want to tackle, right? You want to have people who are knowledgeable about setting up your networks to be able to actually accomplish this. It's a faster, more secure solution when you're finished, but it does require effort, right? There's your VNet connectivity, right? As well, if you're actually trying to do domain, if you're trying to use any kind of DNS functionality, you need to make sure you're actually bringing your own DNS server, hence BYOD. Okay, so those are the kinds of general approaches that you can take when you're actually trying to connect up platform as a service and with the infrastructure as a service. Now, from a testing perspective, like how do you actually go about doing the testing on this kind of functionality? Again, from a developer fabric perspective, so I've created my app fabric. I'm running this thing on inside of Visual Studio. My connection is going to be with 1433, right? So it's going to be my testing is done through the standard SQL Server port, right? Because again, I've pushed my network out to the cloud. Right? The cloud and me are one network. So whether I'm actually running this thing through Azure, through the Azure fabric that's out in the cloud, or whether I'm running it through my emulator sitting on my box, the functionality is still the same. I'm still going to talk to the same SQL server, still going to talk to across the same port number. So the idea that I can test it in this particular manner is not violating the idea that I'm not changing something between deployment and production, right? So because of this, you do have that ability to manage, you've got the ability to do the testing, but I have the potential for having the connection strings happen to change. The connection string that I might use from inside because of DNS that maybe I'm running or some local the naming that I can use to access my server can be different from what I might be using when I'm actually talking to from the Azure website, the services side, from the platform as a service, from my web roles and worker roles. So I have to be able to manage multiple configuration strings in that kind of an environment, and that's not challenging to do. It's just the kind of thing that's a little bit fraught with errors, and it's one of the reasons why you might very well want to create different configs inside of your Visual Studio with the different connection strings, so that as you push your environments from place to place, as you do your publishes, you're actually picking up the appropriate connection string without having to remember to actually make some changes to it. Right? If you actually have some kind of a virtual a VPN set, a virtual private network set up within your organization, you still have the ability to actually do these kinds of connections. So what you're looking at here is on the left-hand side of that slide, you still have a load balance port 80. I still have my Windows Azure web role. I still have my SQL database, my Active Directory, whatever my services happen to be. On-prem, so all of that's running inside of my cloud. On-prem, I've got my developer, its own DNS, its own Active Directory, developer fabric that happens to be running there. And then it's actually possible to set up a VPN tunnel. So that what happens is from your premises, you can actually use a VPN tunnel to get out to the Windows Azure functionality through a secure connection. And now again, you can have that direct connection to the virtual machines. It is like you're running inside of that same network. And from a configuration and execution perspective, things don't change. And that's ultimately, okay, from a pragmatic perspective, that's ultimately where you want to get to. I mean, we're talking about a number of different ways to set up your environment. And, you know, any of them can work in almost any situation. Some may be better than others in certain situations. But this is much more about how you as a developer and how your administrators want to actually configure your system, how you want to allow access back and forth between the two. None of the stuff we're talking about is mutually exclusive. I mean, you can go any one of a number of different ways, and as I said before, there's pros and cons with each. But for the most part, the kinds of applications you write are going to be the same in all cases, and the approach that you as a developer take to writing it are going to be the same in all of these different cases. And that ultimately is where we're trying to get to. I mean, I'm not as I said before, I'm not a networking expert. It's not something that I'm certainly aware of it, and I've had enough challenges in it to be aware of some of the things that can go wrong and some of the things that can go right and how easy or hard it happens to be. But it's not something I actually want to think about a great deal of as I write my applications. I want to write my applications, and then I want to have the deployment be worried about afterwards. That's a little bit of pie in the sky, but it's not a lot of pie in the sky, because it really is how you should worry about it. You don't worry when you make calls to your database. You don't worry about where your database happens to be at the time you're writing the call. You worry about that afterwards, and the connection strings take care of that. And most of what we do when we're dealing with remote services have those kinds of connection strings. They may be connection strings for a database. They may be endpoint references for WCF services. They all work out to be about the same thing. So we don't really want to care about how this works. We just want it to work, and we want to make sure that as we go from one to the other, we don't have any issues. And all of these mixed models allow that to take place. That you have the ability to actually do things like testing and not have it impact what you're writing. And you can do deployment and not have it impact what you're writing. And that really is the ideal situation that we happen to be trying to get to. Right? So now if I'm trying to actually do my virtual network connection, again, I've got 6 steps that I happen to be working with. The first one is probably the toughest one, and this is the one where you're really talking to networking people. You want to define your virtual networks and your subnets. Okay, you want to make sure that your various hosted services, whether you're putting the web and worker roles out there, whether you're putting a SQL server out there, you have to decide what you want to be out in the cloud versus what you want to be on premises. You have to set up the addresses for each one of those, make sure they're sitting on the appropriate subnets. That's just simply a design. I want to say take out a piece of paper and a pencil, but I think we do things like this electronically now. But the basic premise is still, from a design perspective, you need to lay where these things all happen to fit. From a deployment perspective and the customization, it's the same as it was for the virtual IPs. You can grab your virtual machines from the cloud, from the gallery, I should say. You can take your own VHDs. You can publish them out there yourself. Everything happens to be in play from that particular perspective, so there's not really a lot of that you do there. And once you've got your virtual machines, you customize them however you want. Install whatever software you need, do whatever setup, whatever configuration you happen to want to go. We've already talked about the idea that you can do local dev and testing. So in any of the environments we've talked about, you can test things out. And that ultimately, because we're developers and we do nothing but test, That's probably one of the most important things that we want to be able to do. More importantly, and with less tongue in cheek, more importantly, I want to make sure that the stuff that I'm testing will be the same as what actually gets deployed. Okay, that's really what this happens to allow. I basically can test the environment in the same situation using the same, whether it's the emulator or whether it's real. I know that the results are going to be the same and consistent. I don't have to go chasing down well, it worked fine on my machine, what happened when you deployed it kind of bugs. Deploying the service is, again, fairly straightforward. You push your web rules, your worker rules out to where they're supposed to be, configure the number of instances, set your virtual network settings. There's other configuration details that you need. And then as part of those configuration deals, you shut down the stuff you don't need. Right? You shut down the endpoints that were public. You make sure the stuff gets locked down. And exactly what you're going to do there depends very much on what you did in the first step. Okay? So, excuse me. So in terms of mixed mode, when you're using a shared cloud service, right, you're talking about basically having virtual machine, and if you push your virtual machines out to the cloud, along with your Windows Azure web role / worker role functionality, you're now talking about simply having all of this stuff sitting in the cloud. You're not worried about the on-premises stuff at all. And this becomes a lot, this is from a functionality perspective, incredibly easy. Because as long as you're inside of that same cloud service, as long as you're inside of that same environment, you don't actually even need to worry about IP addresses or a DNS. So that DNS functionality, the name resolution functionality, is actually included by Azure. So if I had gone out and called my virtual machine, Azure Demo 1, right? My web role or worker role would be able to just simply access that machine by name. It doesn't have to know it's Azure Demo 1.azurewebservices.net or any one of those, anything like that. It's simply the name is sufficient. So it ends up being a very simple mechanism, and the IDNS basically is what I just said. It will actually identify the names inside of the same cloud environment. From a connectivity perspective, incredibly fast, incredibly secure. It's working across. It's faster than actually going back on-prem. The stuff is all in the same environment. Depending on how you configure it, it might even be in the same machine, although, again, you don't really care about that. But trust me when I say that the latency time here is actually quite low. So it's a very nice, easy way to go. Biggest thing you're going to run into is the lack of being able to swap out virtual IPs, right? So this basically is your load balancer is looking at one. It's going to see that thing as one machine. So you don't have the ability to easily swap things out for other things because some of the simplicity depended upon them being running in that same cloud service. So you do have that as a bit of a downfall. Okay. So we talked about latency a couple of minutes ago. The latency is actually fairly straightforward. We're looking at the chart that you see here. We're looking at two different values. So what we're talking about here is if I'm looking at cross VM, I love the way this is going to read out because this actually sounds so exciting. Inter VM within a deployment. So what I'm talking about here is if I'm taking a look at the same VMs between two VMs or more VMs within a single deployment, or if I'm actually running between two different deployments using virtual networking, my latency ends up being at about just a tad under 30 milliseconds, which is actually quite decent. Now, this is direct IP to direct IP, which is one of the reasons why it's so fast. You'll also notice that last piece, it's not flowing through a load balancer, right? So the fact that it's not flowing through a load balancer and the fact that it's direct IP to direct IP is one of the things that made the inability to swap out virtual IPs a little challenging because the machine is looking for a specific IP. Now, if I'm actually going between VMs, so I'm up in Azure, I am two different VMs in the same region, right? So we're not talking about between Eastern United States and Western United States. So if I've got two VMs, two different deployments, so I'm in two different cloud services inside that same region, you're looking at a tad under 90 milliseconds, 88 milliseconds to be precise. Okay, this is virtual IP to virtual IP, and this is going through a load balancer, which is one of the things that actually explains why it takes a little bit longer to go. So those are the kind of latency times that you're working with. They're not, from a pragmatic perspective, they're not, they're not really noticeable. We've done a couple of different environments, and if I'm going, say for example, I'm going from an Azure website to a SQL Azure database, the latency time from the user's perspective doesn't look to be any different than if I was going from an IaaS server to a SQL database in my own prem. So the latency times seem to be quite in line with what you expect. Right now, if you're trying to skinny as many milliseconds down on latency as you can, you may find there's a lot, but from a practical perspective, I haven't found it to be of particular challenge at that level. There is a concept of tiered migrations, and so this goes back into how you're going to be pushing stuff out there. So the premise here is you're going to want to actually migrate an existing application out into this infrastructure, and so you want to be able to mix your deployment as much as you possibly can. And that's really kind of what we're talking here with the tiered migration. So you can take bits and pieces of functionality and move it out there. And that's really kind of what we were doing at ObjectSharp. We're moving bits and pieces of our internal infrastructure, making them work in a hybrid environment, and slowly but surely kind of pushing them out so that most of them, if not, actually I guess it'll just be most of them, will be out there running inside of an Azure world. So what you end up by taking advantage of this is, especially if you can actually bundle the functionality you're migrating up into the web worker roles. And I realize that the web worker roles is a little bit of a, it's not something that as developers we latched onto with great gusto when it first came out. But as a way to package up pieces of functionality that can get deployed out into Azure, it's actually quite useful. So you can end up, by doing that, you end up with a very simple deployment and configuration model. Very easy to take a web role, very easy to take a worker role and push them out into that environment. You end up with very, the benefits you gain are high availability and instantaneous scaling, because I can just simply crank up or crank down the instances of those web roles and worker roles as I happen to need to be able to do so. Automatic firewall configuration, the fact that the OS happens to be patching. You can do horizontal migration. Okay, and so the idea here is that I've got my Windows Azure role with the different tiers that you happen to have pushed out there. So I do have a web tier, I've got an application tier, I've got a data tier, and I can actually now slowly over time forklift that particular migration. So I can take my web tier and move it out and leave my app and data tier back on my prem. And then I can do the same thing with an app tier, do the same thing with the data tier as I happen to get comfortable with it. So it ends up being quite a nice way to be able to push things around, okay? So again, if you look at this, I can make this move, optionally convert my web apps to web roles, but it is just an optional thing. I don't actually have to do it, okay? Take my app tier, move that up into worker roles, again, optionally. Take my data tier, convert it to Azure, to SQL Azure, and again, do that, not do that as I happen to want to be able to do it. So I've got a number of different choices as I'm kind of taking my various tiers and migrating it out to where I want to go. So basically, just to kind of wrap this up, what we're looking at here, what we've been talking about here is getting connected, the infrastructure as a service and the platform as a service functionality. Incredibly useful pieces of functionality. Each one of these little bits and pieces that happen to be out there, they've all got their place in the different kinds of infrastructure. So to a certain extent, and one of the reasons why Microsoft has been doing a lot of these things is, there's just a lot of these little bits and pieces, and not one size is going to fit for everybody. But a large portion of the stuff that you're doing right now has a place inside these different Azure pieces. Whether you're talking about web roles or worker roles, or Azure websites or mobile services or virtual machines, or any one of the other platforms, the networking components that happen to be out there, all of that is set up so that you can actually migrate as much or as little of your application over whatever time frame you might happen to want to. So you've unlocked the dependencies you have on building applications and on migrating your applications. You no longer have to be able to say, you know, I'd love to be able to move this app up to Azure, but I have this dependency on SQL Server. I don't have access to a database. I've got a SharePoint site that I need to be able to get access to. I'm running Mongo someplace on a Linux platform. I want to be able to get at that. So this becomes a way to be able to transition your environment up to the Azure world. And ultimately, from it's one of those things where, you know, if you haven't already thought about going to the cloud, it's high time. I mean, if you'd said this a couple of years ago, I might have said that no, certain elements of virtualization really weren't there yet. But people have been working through the virtualization on their own premises, and the ability to push stuff out to the cloud has been growing. And one of the things I find with all of the things that we've been talking about all the way along, it's now the time to do it. We now have all the pieces in place to be able to actually make your applications, almost regardless of all of the bits and pieces of dependencies, you should be able to run your applications out there in Azure in some way, shape, or form. And so with that, I believe we're going to take a quick break. We should be back in about, I want to say, probably about 10 minutes or so. And until then, if you have any questions, please ask online. Thanks very much.